Happy Friday, guys. We made it through our first week of distance learning. Today, we're going to go ahead and review for your quiz that you will take on Monday. Your quiz will cover sections 11.3, 11.4, and then the beginning of 11.5, those measures of central tendency, as well as box and whisker plots. So today, we are just going to go ahead and go through the study guide. 11.3, that was our section talking about independent and dependent events. So what happens is you are actually performing an experiment more than one time. So you're going to find the probabilities and multiply them together. Okay, so it says find the probability of each situation. Again, make sure you have your fraction, your decimal, and your percent to get full points. Tossing a quarter 3 times and getting heads each time. So the first time you toss the quarter, your chance of getting heads is 1/2. You perform the experiment again. The chance of getting heads again is 1/2. The third time you flip the coin, you have a chance of getting heads 1/2. So again, you're multiplying the probabilities because you are doing the experiment more than once. So you find each probability, multiply them together. Top times top times top. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. There is your fraction. To turn it into a decimal, top divided by bottom, 0.125. So if I'm rounding to the 100th, I'm going to go to 0.13, 13%. So you have a 13% chance of picking up a quarter, flipping it, getting heads, flipping it again, getting heads again, and then again on that third time, flipping heads. Let's look at the next one. Rolling a 6 on a number cube, then rolling an odd number. So rolling a 6 on a number cube, there is 1 6 out of 6 sides. Then rolling an odd number. So the next time you roll the number cube, there are still 6 sides, so the denominator stays. How many odd numbers? Well, you have 1, 3, and 5. So 3. Remember, when you are multiplying fractions, you can cross cancel. So looking diagonally, I can divide both 6 and 3 by 3. So that would be a 1. And that would be a 2. Top times top, 1 times 1 is 1. 2 times 6 is 12. So your fraction is 1/12. 1 divided by 12 is 0.083. So if I'm rounding it, it would be just 0.08. That equals an 8% chance. Next one, rolling a 3 on a number cube 3 times in a row. There's a 3, 1, 3 out of 6 sides on a number cube. Now you pick it up and you're rolling it again. There is 1, 3 out of 6 sides on a number cube. Now you pick it up and you roll it again. There is 1, 3 and 6 sides on a number cube. Multiply the top, multiply the bottom. Here is your fraction. Turn it into a decimal. 1 divided by 216. I have 0.00. Now, this is an exception to where I'm going to actually round it to the 1,000th versus the 100th. I have 0.46, so I'm going to go ahead and the 46 rounded up to a 5. And so this is 0.5%. It's not even 1%. The reason why I rounded this one to the 1,000th is because if I rounded to the 100th, it would just be a 0. And there is a chance of this happening. I mean, granted, it's only 0.5%, but it's not an impossible situation where we would have a 0. Okay, so if you have something where you do have to throw on that third number, otherwise it'd be a 0, you go for it. A few more examples from 11.3. A bag contains 5 red, 3 green, 4 blue, 8 yellow marbles. Okay, so you have a bag full of these various colors and marbles. When you have a scenario like this, your first step is to figure out how many marbles you have total. So if you add them up, 5 plus 3 plus 4 plus 8, you're going to get 20. Find the probability of randomly selecting a green marble and then a yellow marble if the first marble is replaced. So this is independent because you're putting it back. The denominator is going to stay. All the marbles are going to remain how they were at the beginning. The chance of getting a green. There are 3 green out of 20. So you grab a green marble, you're like, hey, it's green, and you replace it. You put it back. When you go to draw again, there are still 20 marbles in the bag because you put the green one back. Now the chance of getting a yellow. There are 8 yellow marbles. Again, we can cross cancel. 8 and 20 are both divisible by 4. 8 divided by 4 is a 2. 20 divided by 4 is a 5. Top times top. 3 times 2 is 6. 5 times 20 is 100. I can go ahead and divide both top and bottom by 2, giving me 3 over 50. So if I have 3 over 50, that is my fraction. My decimal is 0.06. 6% is the chance of reaching into that particular bag of marbles, pulling out a green, placing it back in the bag, and then pulling out a yellow. Okay, here's another question very similar. A bag contains 12 blue cubes, 12 red cubes, 20 green cubes. So again, your first step is you want to figure out, okay, how many cubes are there? If you add those together, we have 44 cubes. Find the probability of selecting 3 red cubes in a row without replacing them. So that means it's going to be dependent. Remember, dependent, that denominator changes. So you're going to take a red cube out, set it aside, go back to draw again. So at the beginning, there are 44 cubes total, 12 are red. So your chance of getting a red is 12 out of 44. Now you took a red cube out and you placed it aside. So there are only 43 cubes left. You already removed 1 red, so now there's only 11 left. Times, now you took out 2 cubes, so our denominator is down to 42. I had 12 red, I took 1 out, and then I took another 1 out, so now I'm down to 10. Your question on the quiz, that does have you multiplying quite a few fractions like this. I ask you to just give me the decimal and the percentage. So we'll just go ahead, top times top times top, 12 times 11 times 10. You should get 1320. Bottom, 44 times 43 times 42, 79,464. So don't worry about simplifying this fraction, this one on the quiz, because there are quite a few fractions. It will say give me the probability as a decimal and a percent. So 1320 divided by 79,464, 0.016, so 0.02. There is a 2% chance of that happening. Excuse me. First time I've sneezed during one of these videos. Awesome. It's getting more real. Okay, we're going to keep going. Mr. Gamble is drawing 3 cards from a standard deck of cards. Remember, a standard deck of cards has 52 cards. If he does not replace the cards, this is a dependent situation, meaning the denominator is going to change. If he does not replace the cards, find the probability that all 3 cards are face cards. Okay, so there's 52 cards in a deck. Remember, face cards are Jack, Queen, and King, and there are 4 of each because there's 4 suits, and every suit will have 1 Jack, every suit will have 1 Queen, every suit will have 1 King. So there are a total of 12 face cards. So 12 out of 52. Now they're saying that he's drawing 3 face cards, and he's not replacing them. So now there would only be 51 cards left. If he drew a face card and put it aside, now there's only 11. He's holding 2 face cards, so when it goes back to draw for the 3rd time, there's only 50 cards. There are 12 face cards to begin with. He's holding 2, so there's only 10 left. Again, this question on the quiz would be one that says, hey, give me the decimal and the percentage. If you multiply them, 1320. On the bottom, 52 times 51 times 50, 132,600. Turn that into a decimal. 1320 divided by our denominator, 0.00995. So that would bump to 0.01. So there is a 1% chance that if you are working with a deck of cards and you flip them upside down and you shuffle them all around, that you're going to grab a face card and then a face card and then a face card back to back. Kind of a small chance. Last one for section 11.3. Each letter of the alphabet is written on a card. The cards are then placed into a bag, and the kindergarten teacher will draw 5 letters out for today's lesson, not replacing the cards. Find the probability that the teacher will draw 5 consonants. Now remember, a consonant means it's not a vowel. Our vowels are A, E, I, O, and U. So there's 1, 2, 3, 4, 5 vowels. Well, if I have 26 letters of the alphabet and we're focused on consonants, if I minus out the 5 vowels, that means that there's 21 consonants. So they're drawing 5 letters. So out of 26 letters of the alphabet, 21 are consonants. They said, okay, you're going to do this 5 times and they're always going to be consonants. So if I go ahead, each letter of the alphabet, there we go. So I drew 1 letter out, so we no longer have 26 letters in there. There's 25 left. You already pulled a consonant. That leaves 20 consonants left. You pulled out another one, so it goes down to 24. You pulled out another consonant, so now it's down to 19. Then we have 23 on the bottom, 18 on the top, 17 over 22. Again, this one, I'm not expecting you to give me one big fraction and simplify it. Just figure out this as a decimal and a percentage. So top times top times top times top times top. 21 times 20 times 19 times 18 times 17. Kind of fun stuff. 2,441,880 is what we get from the top. 26 times 25 times 24, 23, 22. The bottom, 7,893,600. Go ahead and divide those. 2,441,880 divided by 7,893,600. And I got 0.309, so 0.31. So your answer would be 31% chance that in that scenario, the kindergarten teacher is going to have all of the letters of the day, all 5 of them will be consonants. Those are the things from 11.3 that you will see on the quiz. Let's go to 11.4. 11.4 are inclusive and exclusive events, meaning that you might have that overlap. This is where you're adding and subtracting the probabilities because you're looking at different scenarios, not performing an experiment more than once. You're saying, what are the chances of this occurring if you were to do that experiment one time, okay? It says, apples are in 1/4 of the lunch bags that are distributed at a school picnic. Bananas are in 1/3 of the bags. What is the probability of randomly choosing a lunch bag that contains either an apple or a banana? Now, this is exclusive because you're getting one or the other. There's no such thing as an apple-banana. That's kind of a fun word. Okay, you're either getting an apple or a banana, or maybe they have other fruits in there. They're not telling us. They probably have pears or oranges or whatnot. But your probability of choosing a lunch bag that contains either an apple or banana, chance of an apple is 1/4, plus chance of a banana is 1/3. You're adding them because you're only doing one trial. You are choosing a lunch bag, okay? You cannot add fractions unless you have a common denominator. So my common denominator here would end up being a 12. So I'm turning the first fraction into 3/12. I'm changing the second fraction into 4/12. Your common denominator carries on over, so it's a 12. 3 plus 4 is 7. 7 divided by 12 is 0.58. So you have a 58% chance that you will either get an apple or a banana. That means you have a 42% chance that you're getting some other fruit. Okay, here's another one. A group of senior citizens have won free vacation packages. The vacation to Bermuda is chosen by 25% of the senior citizens. 60% are going to Alaska, and 15% chose Costa Rica. What is the probability that one randomly selected senior citizen chose to vacation in Costa Rica or Bermuda? Okay, again, this is exclusive events. You can't choose to go to more than one. You're choosing either Alaska or Costa Rica or Bermuda. Now, what they want us to do with our probability. What is the probability that one senior citizen chooses to go on vacation to Costa Rica or Bermuda? So you find these two probabilities and you add them together. Costa Rica, 15%. Bermuda, 25%. You just add the two percentages together, that's 40%. As a decimal, it's 0.40. And 2/5 is 40%. And let's keep going. You guys only have one more page left, and that's it for the week. Okay, so we are still on 11-4, where we're adding and subtracting those probabilities. Pam rolls a number cube. It has 1, 2, 3, 4, 5, or 6. Find each probability. That Pam rolls a 3 or a 6. Exclusive because you can't get, there's no overlap here. It's a 3 or a 6. One number out of the 6 is a 3, plus one number out of the 6 is a 6. If you add them, you already have a common denominator, so that's awesome. Top 1 plus 1 is 2. You can reduce that to 1/3, which is 0.33. 33% chance that if you roll a number cube, you will get a 3 or a 6. Okay, let's look at the next one. Pam rolls an odd number, so 1, 3, or 5, or a 3. This time I have an overlap, so this is where you'll have to subtract. There are 3 out of 6 that are odd numbers, plus 1 out of 6 that is a 3, minus one value occurred in both scenarios. My common denominator stays. 3 plus 1 is 4. 4 minus 1 is 3. 3 over 6 can be reduced to 1/2, which is 0.50, which is 50%. Let's look at another one. Pam rolls an odd number, 1, 3, or 5, or a number greater than 4. So you can't include 4. Greater than 4 is 5 and 6. So again, this time I will have to subtract because there's some overlap. There are 3 out of the 6 sides that are odd. There are 2 out of the 6 sides that are greater than 4, minus one of those values. The 5 was counted twice because it was part of both groups. So minus the one value that occurred in both groups, my denominator stays. 3 plus 2 is 5. 5 minus 1 is 4. I can reduce 4 over 6 to 2/3, which is 0.6 repeating. So if I round it, it's 0.67. So there would be a 67% chance of that occurring. Okay, now here are those fun Venn diagram things. Of the 65 students going on the soccer trip, so 65, that is the denominator. That's how many are going total. There are 43 players and 12 are left-handed. Only 5 of the left-handed students are soccer players. Okay, so we have soccer players. It tells us that there are 43 players. So when I add the two values that are going to end up in this region, whether it be an overlap or not an overlap, this has to add up to 43. 12 are left-handed. So when I am adding up the numbers in this oval, it has to add up to 12. 5 of the left-handed students are soccer players. So that's our overlap because we're looking at soccer players and people who are left-handed. 5 of the left-handed are soccer players. So this number right here is a 5. So how many people are left-handed that are not soccer players? Well, 12 minus 5 is 7. How many of the soccer players are not left-handed? There's 43 players. 5 of them are left-handed, so 38 of them are right-handed. What is the probability that one of the 65 students on the trip is a soccer player or is left-handed? Well, there are 43 soccer players out of the total 65. Plus, out of the 65, 12 are left-handed. Minus, we have an overlap. We have 5 who are both soccer players and left-handed, so minus 5 out of our 65. Common denominator is 65. 43 plus 12 minus our 5 from the overlap, we have 50 over 60. Or sorry, 50 over 65. We can reduce that by dividing both top and bottom by 5. You would have 10 over 13. Turn it into a decimal. 10 divided by 13 is 0.769, so it's 0.77. 77% chance that if you selected somebody, students who are going on the soccer trip, you're either going to end up with somebody who is left-handed or they are a soccer player. Last section, guys. It says the probability distribution. Now, probability distributions, they're awesome for making predictions, okay? The probability distribution of temperatures in degrees Celsius from a chemistry experiment is shown below. Okay, so the outcome, the degrees in Celsius, 2 out of the 13 times the temperature was 4 degrees Celsius. 4 out of 13 times the outcome was 5 degrees. 3 out of 13, it was 6. 4 out of 13, it was 7. 2 out of 13, it was 8. So if you were to perform the experiment, if you want to make a prediction and say, okay, what do I think the temperature is going to be? You could find probability distribution by saying, okay, 4 degrees Celsius showed up 2 out of 13 times, plus 5 degrees Celsius, that occurred 4 out of 13 times, plus 6 degrees Celsius, that was 3 out of 13 times, 7 degrees happened 4 out of 13 times, and 8 degrees showed up 2 out of 13 times. So again, what was the solution or what was the result? This is the temperature. This is the times or the probability that it occurred based off of the trials. 2 out of 13 was 4. 4 out of 13, the degrees in Celsius was 5. 3 out of 13 went with 6. 4 out of 13 went with 7. 2 out of 13 went with 8. Now you can actually just plug this in your calculator using that fraction bar. So 4, 2 over 13, plus 5, 4 out of 13, plus 6, 3 out of 13, plus 7, 4 out of 13, plus 8, 2 out of 13. So what you can predict, if you were to go and do this experiment one more time, if you were a betting person, you would bet that, okay, the temperature is going to be approximately 6 and 12/13. So you would say, I'm guessing it's going to fall about 7 degrees Celsius. So that's probability distribution. Okay, box and whisker plot. Main thing here is make sure that you have your numbers in numerical order before you start. So the smallest number I see is a 1, and there are 2 of them. So you rewrite the 1 twice. I see 1 4, 1 2 5s. We got a couple 7s. Next smallest number would be 9. We got 2 of those. And I'm going to keep looking here. 13s. 1, 2, 3 13s. 17. I got 2 of those. 1, 2, 3 20s. And a 21. Okay, so that's step 1. If you are making a box and whisker plot, you got to make sure you put the numbers in order. Your 5 key points. You need the minimum value, the maximum value, quartile 1, quartile 2, quartile 3. Remember, quartile 2 is actually your median. It's the middle value. Your minimum value, in this case, the smallest number is a 1. Your largest value was 21. You do have to find Q2 first because that separates your data into an upper and a lower portion. So 1, 2, 3, 4, 5, 6, 7 off the front. 1, 2, 3, 4, 5, 6, 7 off the back. 1 off the front, 1 off the back. Okay, I have 2 numbers in the middle. So this is your Q2. You have to figure out exactly what's in between 9 and 13. And again, what you're doing is finding the average of those. So if I take 9 plus 13 and you divide it by 2, it tells you exactly what's in between the 2. Or you could say, okay, there are 4 units between 9 and 13, so you meet halfway, 2 units before 13 and 2 units after 9, you get 11. Okay, so however you're comfortable doing that. Now this is your median. So that is not an actual number, so your 9 gets to be part of the lower half. Your 13 is part of the upper half. When you are finding Q1, Q1 is the middle of the bottom part. So 1, 2, 3 off the front, 1, 2, 3 off the back, 1 off the front, 1 off the back. We have a number in the middle, and it's 5. And now this should even out. So if you look, I have 4 numbers to either side. So if I go here, I can go 1, 2, 3, 4, 1, 2, 3, 4, and I do have my 1 number in the middle. Q3 is 17. Okay, so I'm going to go ahead and make this box and whisker plot. We have to go all the way from 1 to 21. 1, 2, 3. You guys counting out loud? Okay, Okay, that ended up working perfect. Okay, so go all the way from minimum to maximum, 1 to 21. Now above the line, you're going to go ahead and put each of these key points and then label it. So above the 1, you put a point. That is there because that's a minimum. Above the 21, you put a point. That's the maximum. Above the 5, Q1. Above the 11, Q2. Above the 17, Q3. So those are your 5 key points. What happens here is now you can go ahead and make your box and whisker plot. The box goes from Q1 to Q3. The median, so you put a line down Q2. Connect the whiskers. It says be sure to label all the necessary points. Find the interquartile range. Remember, interquartile range means you take your third quadrant minus your first quadrant. So 17 minus 5 is 12. That tells you how many units there are between, or how many units long is the box. Okay, we have one more question, and that is our review, and this is your only assignment for today, is just to do the study guide with me, okay? And then you're done for the week. Just enjoy your weekend, guys. Mean, median, and mode. Step 1, again, you want to put the numbers in order. There are 2 2s. There's a 3, 1, 2 5s, 7, 8, 10. Okay, your mean. Remember, the mean is when you add them all up and divide by how many terms you have. So 2 plus 2 plus 3 plus 5 plus 5 plus 7 plus 8 plus 10. 42. You divide it by 1, 2, 3, 4, 5, 6, 7, 8. 42 divided by 8, your mean is 5.25. Mean is also called the average. The median. The median is the number in the middle. 1, 2, 3 up the front, 1, 2, 3 up the back. We have 2 numbers in the middle, so your median is actually whatever's exactly between those two. In between a 5 and a 5, we have a 5. Your mode is the number that occurs the most often. We have 2 of them. We have 2 and 5 because both 2 and 5 occur 2 times, whereas 3, 7, 8, and 10 only occur once. So guys, that is what we have covered so far with our distance learning. I hope you enjoyed doing the study guide with me. The quiz is on Monday. Enjoy your weekend. I miss you much. Can't wait to visit with you again next week.